okay? So this is the triangle proportionality theorem. So if these two segments, for example, what two segments need to be parallel in order to use this theorem? EB and DC, right? So check this out. If AB's length was, for example, 2, and BC's length was 3, EB's was 4, and ED's was 6, right? Guys, this proportion will hold as long as those two lines are parallel. So we can take AB's length, which is 2, put it over BC's length, which is 3, and set it equal to AE, which is 4, over ED, which is 6. What is 4 over 6 simplified to? 2/3. So do you see how it holds for this problem? This will always happen as long as these two segments are parallel to one another, okay? Now, it also works in reverse, okay? So the converse of the triangle proportionality theorem says, if you have that proportion, right, AB over BC equals AE over BD, then you're concluding the following. You can conclude that those two segments are parallel to one another. So I would put those parallel markings in red so you can see that that's your conclusion now for the converse, okay? If that proportionality holds, then we know that the lines are parallel. Did we all get that copied down? Okay. All right, guys, let's do an example. So if we already know, based on the diagram, they have these parallel markings here, okay? If we know that those two lines are parallel, putting CD over DA is going to be proportional to what? EC or CE over what? BE. Very good. Okay? Now, we're going to do C first, and then we will do B, okay? C says if CB's length, that's the length of the whole thing, if this entire thing was 12, and EB was 8, CD was 6, how do we find DA? So let's put a question mark. We're looking for DA. Again, guys, we're doing C first, and then we'll do B last, okay? Because they're different problems. Hannah? Very good. Subtract 8 from 12 to find this missing piece. What do you get? 4. So now let's set up our ratio, right? We said that CD over DA equals EC over BE. Do we know what CD is? 6. It's 6. We put that over DA. Is DA known? Let's put X. Very good. So let's make sure that we identify that that's going to be our X. What's it proportional to? It's proportional to EC over BE, correct? Guys, we're using this formula. What's EC?
4.
What's ED? Or EB? 8. Now, before you cross multiply, what should you do? Simplify. 4 over 8 simplifies to 1/2, so let's rewrite it. It's going to be 6 over X equals 1 over 2. What do I do now? Cross multiply. What's 2 times 6? 12. What's X times 1? X. So X equals 12. So we just found DA is 12. Does that make sense? Are there any questions on that example? Okay. Now, if you want to put a star next to letter B, this is probably one of the most common mistakes you'll make with this lesson, okay? In letter B, it says CD is 3, DA is 6, DE is 3.5, then find AB. Now, to do this one, I want you to draw the picture again because we're going to fill it in with different letters. So draw the whole picture again, the upside down triangle with the parallel line going through the middle, E and D, B and A, and this bottom one should be C. Now let's fill in our diagram. It says CB. No, we're looking at number 2. CD is 3 units. DA is 6 units. DE is 3.5. And AB is our unknown. So we'll make that our X. That's what we're solving for. You guys, you can only use the triangle proportionality theorem if it's the two sides that are touching the parallel side, the parallel line through the middle. This is not an example where we can put 3 over 6 and set it equal to 3.5 over x. This is an example where we have to use the numerator and the denominator, like the small triangle and the big triangle, okay? So check this out. We're going to say CD is proportional to CA. This side right here of the small triangle is proportional to the entire length of the larger triangle, that same side. Do you guys remember that? This is how we used to do these problems. Now that's going to be equal to ED over what? BA. Or AB, okay? That order doesn't matter. So now what is CD, guys?
3.
3, right? What is CA, though?
9.
It's 9. You have to add those values together. Equals ED, which is what? Not X. 3.5. And then AB, which is? That's going to be X. Before I cross multiply, guys, what do? 3 over 9 becomes 1/3, so it's going to be 1/3 equals 3.5 over X. Now I cross multiply. What's X times 1?
1x.
1x or just X. And then what's 3 times 3.5?
9.
I don't think so.
10.5.
10.5. And that's your answer. Okay? Hey, all iPads need to be face down right now. No screens. I need you to understand that hey, look at this. When you are comparing those two, do you see how we knew one of the parallel sides? We're comparing it to the other parallel one. You cannot use the proportion 3 over 6. Do you see that? You can only use 3 over 6 when you're comparing it to BE and EC. That is the big mistake, okay? Don't let that happen to you. Don't be that person, okay? All right, let's move on. You can turn your iPads over. Thank you for speaking up. So, Christian, do you see how over here we just said, okay, 4 over 8 is proportional to 6 over x? We cannot do that in the second example because they're not comparing the two sides that are cut by the parallel line. They're comparing this base side to this base side. And those are part of large triangles. Do you see that? So we can't use that same ratio. We had to use 3 over 9 because 3 over 9 is the small triangle over the large triangle. Does that make more sense? Okay. All right. The next theorem that we're learning is the 3 parallel lines theorem. Okay? Yes? You didn't understand what I just said? Okay, let me go. Now, in this one, okay, as long as 3 lines are parallel and they're cut by 2 transversals, okay? There has to be 2 transversals. It divides it proportionally, okay? So we're going to do the exact same thing here. We're going to say, okay, this top part will be my numerator. This bottom part will be my denominator. Let's fill in some values. Let's say BC was 4 and CD was 5. And let's say AF was 8 and FE was 10. So watch, the ratio that holds is BC over CD, in other words, 4 over 5, is going to be proportional to AF over FE. So it's going to be proportional to 8 over 10. Okay? That piece between the top 2 parallel sides is proportional to the piece on the bottom of the parallel sides. Okay? And then we simplify this and we divide by 2, you get 4 over 5. The 3 parallel lines theorem. Now, keep in mind, guys, there has to be 2 transversals here, okay? It's almost like a triangle that you don't actually see where they intersect.
So all 3 of those lines in the middle are parallel?
All 3 of those lines in the middle are parallel. All right. Let's check out an example. So if we're going to get 4 sections. We're going to get section A, section B, section C, and section D. It says A is 2, B is 3, C is 5. Then D must be equal to what? Let's fill that in. 2, 3, 5, and an unknown. We'll leave it as D. Who wants to set up the proportion for me? Nick?
2/3 equals 5x.
Very good. AB over C over D. That's going to be our proportion. Remember, numerator, denominator. And we're going to say, okay, A, which is 2 over 3, is going to be equal to 5 over x. Cool? What do I do from here? I cross multiply. Can I simplify before? No, because there's no common factors between 2 and 3. So we cross multiply, we're going to get 2 times x, which is just 2x, and 3 times 5, which is equals 15. Divide both sides by 2, you get x equals 7.5 or 15 over 2. Either way, that's the right answer, okay? Any questions on solving for D? No, we're good? All right, I want you to try B, solve for D, and then add C and D together to get C plus D. Let's see what you get. Go. All right, how many of us got 15? Very good, okay? Guys, D's length was how long? 10. But that's not our answer. It wanted C plus D. What was C's length? 5. So add 5 and 10 together. What do you get? 15. How'd we do? Does it make sense? Okay, so we still have one more theorem, guys, okay? The last theorem is the triangle angle bisector theorem. Now, it's the exact same thing. It's going to create a proportion for us, okay? Now, there's a very, very, very important misconception that happens in the triangle angle bisector theorem, okay? So pay close attention when I go over that, that misconception. It says if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides, okay? Sounds very complicated, but basically what happens is you're going to say AD over DB. Those two are going to be proportional to each other by the same proportion that AC is proportional to CB.
What is?
Okay? So as long as that's an angle bisector, that means it cuts the angle in half, you get proportions of the sides. So for example, let's fill in some numbers so we can visualize it. Let's say AD was 3, DB was 2. And let's say, actually, hold on. Let's not make it 2. Let's make it 6. And let's say AC was 5, then CB was 10. So if we put 3 over 6, that proportion should be the same as 5 over 10. And they both reduce to what? 1/2. Okay? Now, we're going to put the same N and D on our triangles for numerator and denominator, but the misconception is that these two triangles are similar to one another. They are not, okay? You probably want to write that down. These two triangles are not similar to one another. Okay? The triangle on top, above the angle bisector, and the triangle below the angle bisector. Although they have proportionality of their two sides, they are not similar to one another. Now, why aren't they similar? Well, do you guys agree that they share a side down the middle?
Yeah.
That CD is a side used for both triangles. So they should all be proportional by the scale factor, correct? But they're not, because that side down the middle is congruent for both of them, right? And when you have congruent sides, the scale factor is 1, right? You're not changing the size at all. But the other two are saying change it by 1/2, right? You're dividing it by 2. So that's why these two triangles are not going to be similar to one another. Okay? What part don't you get?
That explanation as to why they're not similar.
Okay, so the scale factor says divide by 2, correct? Or multiply by 2. 3 times 2 gives me 6. 5 times 2 gives me 10. But Hannah, if this side length is 7, 7 times 7, it's a shared side, so it can't be 14 down here. Do you see the difference? So just understand, these two triangles, they're not similar, okay? They're just proportional with their other two sides, okay? All right, go ahead and take a look at the last 3 examples. So if we know that those two angles are congruent, we know that it's an angle bisector. we can set up some proportions. So BC over CD is going to be proportional to what? AB over AD. Very good. And now we just plug in with what we know and what we don't know. BC is how much? 18? CD, what are we going to put there? Y. Very good. AB is what? 42. And the last one is 63. Okay? You can simplify it to 2/3. How? What are they both divisible by? 21. I personally did not notice they were divisible by 21. I noticed they were divisible by 7 first. So I would divide by 7 first, and I would get 6 over 9, right? So 18 over y equals 6 over 9. Then I was like, oh, they're both divisible by 3 now, right? So I would have divided by 3, and I would have gotten 2/3. So 18 over y equals 2/3. Now I cross multiply, I'm going to get 54, because 3 times 18 is 54, equals 2y. Divide by 2, I think y is 27. Yes. Any questions on this? So guys, once you set up the proportion, it's very easy. But getting that proportion right every time, that's the challenge for you guys, okay? Is knowing which values to put over one another, okay? All right, let's check the next one. In the next one, we're solving for the value of x, right? Now, before you start, I want you to look at this piece. Is there a way to represent that piece? Juliet? It's not going to be 10. Let's think about it. Yeah, Christian? It's not 20. Well, it is eventually going to be 20. Yeah, Juan? Very good. It is x minus 10. Why is it x minus 10, Juan?
Because you need to subtract 10x to get.
Very good. So you guys know that the whole length of it is x, correct? And then subtract this 10 piece, and aren't you left with the piece that you want? So if we do x minus 10, that's going to represent that piece. Now, let's set up our proportion. Remember, these two angles are congruent, so I know it has to be 10 over x minus 10 equals, that's going to be proportional to what? 12 over 24. Now, some of you, I already know, are looking at this and you're like, I already see that it's 12 times 24, or 12 times 2 gives me 24. So that one triangle on the bottom should be double, right? The triangle on the top. So you're like, okay, that length must be 20. Yes, that works for this problem, but I'm going to show you what'll work for every problem if you can't notice that scale factor right off the bat, okay? All right, so what do I do from here, guys? Simplify. Very good. So it's going to be 10 over x minus 10. That one doesn't simplify. What does it simplify on the right to? 1/2. Very good. Now we cross multiply. What do I get? 20 equals x minus 10. What do I do? Add 10 to both sides. You get 30 equals x. So the length of that entire bottom base of the triangle is 30 units, which makes x minus 10 how much? 20. Very good. We Gucci? All right. I think our last example. Okay. So guys, we initially don't know that these lines are parallel. It doesn't say that to us. But we do know that all three of these angles are congruent. Do you guys see those markings there? Do you guys know what the relationship between those angles are? Yeah? They're corresponding. Very good. And if corresponding angles are congruent, that lets us conclude that these are parallel, okay? So if you see this happen again, just remember, okay, those are corresponding angles. These should be congruent to one another, or excuse me, parallel to one another. All right, so since they're parallel, we can set up a proportion. And remember, we're finding DF, which is going to be the length of the whole thing. In order to find that, though, we first need to find the length of EF. So let's set up our proportion. We're going to put AB over what? BC, because this will be our numerator, this will be our denominator. Do you guys kind of see that? Remember, look at the parallel lines. There's 3 of them, right? It's going to divide it into 2 different sections, a top section and a bottom section. That's going to be proportional to DE over EF. So now we know what AB is. AB is what? 30. What's BC? 12. DE is 35. And EF? Let's make that X. Simplify 30 over 12 first. You're going to divide both by 6. That'll give you 5 over 2 equals 35 over X. Now we cross multiply. What's 35 times 2? 70. And what's 5 times X? 5X. Divide both by 5, and I believe you get X equals 14. Okay, that is not the length that it wanted me to find.
You add 35 plus 14 and you get 49.
Very good. We needed DF, which is going to be 35 plus 14, which gives me 49 units. Once you're done with this one, go ahead and turn it in.